In this video, I'm going to talk to you about part 3, numbers 2 and 3 of Hess's Law Lab. This goes to verifying Hess's law. So your first step is to look back at number 1 from part 3 at the net ionic equations that you wrote. Your goal is to rearrange equations 1 and 2, the blue and purple ones, into something that when you add them together, it'll equal equation 3. So I just want you to notice in that first equation, we have an H plus, just like in our last equation. So think about if you need to do anything to that first equation and what you would need to do if you need to do something. In our second equation, I want you to check out that ammonium ion and notice that we also have an ammonium ion in our final equation. So do you need to do anything to that second equation? It doesn't need to be flipped, doesn't need to be multiplied by anything. Figure that out. So that would answer number 2. So the answer to number 2 is how do you rearrange the first 2 equations to get to your last equation? Then for number 3, and so then the second step for number 2 is to figure out the delta H of our last reaction based on our first 2. So I'm just going to give you an example. So let's say our first reaction's delta H was 50 kilojoules per mole, and our delta H for the second reaction was 3 kilojoules per mole. So now, whatever you did to the first 2 equations in order to get to the third equation, you also need to do to their delta H's. So let's say you decided to flip the second equation. Well, that's like multiplying it by a -1. So delta H no longer is that. Delta H now would equal -3 kilojoules per mole. This is just an example. I do want to remind you that both of these reactions were initially exothermic. They produced heat, so all of our delta H's should initially be negative. So then, to get the delta H of our third reaction, all we would do would add our first reaction delta H. We're just going to add our first reaction delta H to the flipped version of our second reaction delta H. So not that number, but this number. And we would get our final delta H would be 47 kilojoules per mole. And so now, for part 3, find the percent difference between the calculated and measured values for delta H for the third reaction. You are going back and using number 3 from part 2, the change in delta H that you've already calculated for this reaction based on the temperature change that occurred during that reaction. And now you are comparing it to the value that you just calculated. So you will be doing the following equation. And your measured is what you calculated based on the lab data. So using that Q equals MC delta T equation, the change in temperature of the solution and the solution's mass for solution number 3. And that delta H that you calculated based on that, that's your measured. The calculated delta H is what we just did, the delta H from Hess's law. And you divide all of the absolute value of the difference between those by the measured and multiply that by 100%.